In a Y-to-Y transformer step down, the configuration will look like this, but it is easier to represent like this, where the primary winding is shown on the left and the secondary is shown on the right. In fact, this representation may be the one that depicts the factory transformer where the secondary side is brought into the plant to the switchgear. From the switchgear, the power, as we know, will be routed to the rest of the plant, where other transformers will be used to provide the appropriate voltages and currents required by each branch circuit. Note that in this one-line diagram, we represent the transformers like this. Furthermore, we'll find that we may even include the Y-to-Y or Y-to-delta, etc. transformer configuration. The three-phase power from the switchgear is represented like this. Additionally, the neutral line may also be included in the power distribution media, such as busways, which we'll see later. This neutral line may also be grounded. As it is distributed through the plant, this power representation will be feeding to other transformers. In here, we may use this kind of configuration when the coils for each phase of the transformer are represented. If we want to represent a Y-to-Y transformer connection here, we would connect the lines to each transformer coil like this. The incoming power lines are connected to the H1 side of the transformer. In transformer nomenclature, the sides with the H's, H1 and H2, are used for the high voltage, where the X's, the X1 and X2 sides, are used for the low voltage. Note that the fourth wire, the neutral in this example, is grounded and connected to the H2 side of each transformer. Let's go over this transformer wiring to make sure that we have it wired in a Y configuration. Tracing from line A to the first coil's H1 terminal, we go through the coil to H2. This H2 terminal of the first coil goes also to the neutral. From line B, we go to H1 of the second coil, through it to its H2, which also goes to neutral. Similarly, the C phase goes to H1, through the transformer coil H2 to neutral. As we can see, this representation is a Y connection with a neutral wire. The secondary also follows in the same manner. This Y transformer connection can be traced for line L1 to X1 through the coil to X2 and neutral. The same is true for the line L2 and also for line L3. This is a Y-to-Y transformer connection. The three stepped-down voltages, one for each phase of 120 volts, came from the X1 and X2 side of each of the transformers. Here again, each of the X2 sides is connected together to form a neutral, and also all three are grounded. In this configuration, the stepped-down voltage is 120 volts from 480 volts, a 4-to-1 step-down. Note that each of the phases is being stepped down and passed accordingly. Also remember that the voltage between phase 1 and neutral is the transformed 120 volts and between phases. The line voltage will be 1.73 times 120 volts, or 208 volts. In this power distribution configuration, we could connect a three-phase 208 volts motor, a one-phase 208 volts, receiving the 208 volts from lines 1 and 2, and in the same system, we could also have a one-phase 120 volts, which will be connected from any of the three lines L1, L2, or L3. In this case, L3, to the neutral of the Y transformer. We could also have a connection like this in a branch circuit, which is perhaps applying a 120 volts lighting system. Note that in this small example, we have connected each of the 120 volt lights to different phases to try to maintain a balanced load for all phases.